Let's graph y equals 1/2 to the exponent x. I've got a table of values. We're going to choose our x values here. So we're going to plug 1/2 into the -2. Remember, with the negative exponent, you take the reciprocal, so that it becomes a positive exponent. So 1/2 to the -2 is 2 squared, which is 4. 1/2 to the -1 is just 2 to the 1, which is 2. Anything to the exponent 0 is 1. 1/2 to the exponent 1 is just still 1/2. And 1/2 squared is 1/4. Let's plot these points. We need a scale, so we'll put in our scale of 1 and we'll plot each point. So -2 and 4. Good idea to put 4 there. -1 and 2. 0, 1. 1 and 1/2. 2 and 1/4. So again, it will have arrowheads at each end as it will continue in both directions. And just like before, there will be a horizontal asymptote at y equals 0 as it continues along the x-axis but does not touch or cross it. The domain of this graph is xy reals, or if we write it in interval notation this time, it would look like this, -infinity to +infinity. The range, you can say y is greater than 0, or if we wanted to look at what that looks like with interval notation, it would be 0 to infinity, a round bracket around the 0 as it is not including the point 0. There's a horizontal asymptote at y equals 0. There's a y-intercept at 1. There is no x-intercept, and because it goes down as you read left to right, it is decreasing. So what we're going to notice is that exponential graphs, unless there is a movement up or down or right or left, are going to have a common point at the y-intercept of 1. So common point will be at y-intercept equal to 1, or 0, 1 if you're writing it as a point on the graph.